As any good Potterhead shall tell you, the difference between muggles and wizards goes far beyond the magical gene. In fact, the segregation between muggles and wizards is so extreme that each has a separate world. The wizarding world is hidden, invisible to muggles. And in the muggle world, magic is just a fantasy, something that exists only in fiction. Unfortunately, though, all these rules have been thoroughly violated ever since a highlights video from the Quidditch World Cup semifinal got leaked onto the Muggle internet. The secret of the wizarding world is out, and the mind-blown Muggles are excited to learn more. But the Ministry of Magic is cautious about opening their society to the temperamental Muggles and has devised a plan to test the waters first. They will invite only one Muggle camera person into their world to film the Quidditch World Cup final and broadcast it to Muggle TV. If the Muggles can watch the game with support and respect, then the wizarding world will embrace them. Otherwise, the wizarding world will shut them out for good. Jason is the camera person selected for the task and hooks a quadrilateral zip line to the circular rim of the Quidditch stadium. He'll be able to maneuver his camera pod around this cyclical quadrilateral wire to get clear and dynamic shots of the sky-high sport. The game begins, and at first, everything is hunky-dory. The players swoop and dive, and the Muggle viewers cheer with glee. But then, one of the beaters smacks a bludger with all his might, and it goes careening towards Jason's camera. Luckily, the camera itself still works, but the camera pod has lost some data. In particular, it's lost angles DCB and ABC. These angles are crucial for the camera's ability to turn around the two respective zipline corners. Until Jason re-enters the exact angles, he'll be severely limited in what he can shoot, and the Muggles will probably miss most of the nail-biting action. He knows that since the zipline is attached to a circular rim, ABCD forms a cyclic quadrilateral. Given that angles DAB and ADC are still readable from the camera's surviving data, can Jason compute the values of angles DCB and ABC to resume the broadcast? If so, prove how. Since letters A, B, C, and D form a cyclic quadrilateral, we can say that line segments AB, BC, CD, and DA form chords of the circular rim. Given that chord AB partitions the circle into two segments, we can say that it subtends angle ACB and angle BDA in its major segment. Similarly, chord BC subtends angles BDC and CAB. Chord CD subtends angles CAD and DBC, whereas chord DA subtends angles DBA and ACD in their respective major segments. In fact, in this process, angles A, B, C, and D have also been split into two smaller constituents. But since reading them repeatedly can get quite confusing, it's best to number them as 1, 2, 3, 4, all the way up to 8. Using this technique, angle DCB can be expressed as angle 5 plus angle 6. And angle ABC can be expressed as angle 3 plus angle 4. In short, we need to compute the value of angles 5 plus 6 and angles 3 plus 4, using the value of the remaining 4 angles. One way to do so is by invoking the angle sum property of a quadrilateral, which states that the sum of all internal angles of a quadrilateral is equal to 360 degrees. Mathematically speaking, the sum of all 8 angles is equal to 360 degrees. Here, we see that angle 3 is equal to angle 6. This is because angles belonging to the same segment are equal in measure. Similarly, angle 4 is equal to angle 1, angle 7 is equal to angle 2, and angle 8 is equal to angle 5. Using these new equations, we can replace angle 3 with angle 6, angle 4 with angle 1, angle 7 with angle 2, and angle 8 with angle 5. The left-hand side of the expression can now be written as twice of angle 1, plus twice of angle 2, plus twice of angle 5, plus twice of angle 6. On dividing both sides of this equation by 2, we can conclude that angles 1, 2, 5, and 6 sum up to 180 degrees. In other words, the sum of opposite angles DAB and DCB is equal to 180 degrees. Similarly, we can show that the other pair of opposite angles labeled as ABC and ADC also add up to 180 degrees. Since each pair of opposite angles of a cyclic quadrilateral are supplementary in nature, Jason can calculate angle DCB by subtracting DAB from 180 degrees, and calculate angle ABC by subtracting ADC from 180 degrees. Having found both the angles, Jason inputs them into his camera pod and is soon swooping around with the Quidditch players once again. Mesmerized by the magical game, the muggles soon forget the hiccup and go back to chanting for their soon-to-be allies in the wizarding world.